instead of IPv4, we're going to use IPv6 address. Okay, the addressing format is changing, routing, everything is same. Understand? No? अभी computer addressing format के लिए आपको पुराना हमने पढ़ा था ना IPv4 subnetting में. That time we studied the format, so we'll revise it now. A long time back we studied. No? What is the length of IPv6 address? Is 128 bits. Bits means what? 128 zeros or 128 ones. Like that, the address will be the actual address. But we cannot speak in bits, right? Zeros and ones. So we will represent other numbering system. 32 hexa digits. One hexa equal to, for these 16 numbers, total 16 numbers. Okay, these 16 numbers we will be using 30 to 16 numbers. 32 hexa digits. Understand? The address can be like this: A, B, 9, 7, like that address. Understand? Okay. Can use A, B, C, D also. 0 to 9 also. Okay. So if you take one hexa digit, like for example, I will take F. If I convert into this binary zeros and ones, it will be 4 ones. 1, 1, 1. One hexa equal to 4 bits. You got it, no? Okay. Yeah. If I give an IPv6 address, if I want you to convert into binary, one hexa equal to 4 bits. So 32 into 4, how much? 128. No, 32 into 2 is 64. 64 into 2 is 128. So this full range, if you see how that IPv6 address looks like, it will be starting from 00000 to. Now if I see how it is divided, right? This 32 digits, no? Hexa digit divided into colon 0000. 0000. How many groups it is? 4 groups, right? Every group I put colon, right? Okay. So again, one more 4, total 8 groups. Yeah. How many groups? Each group will have 4 hexa digits. This is the way. This is actually IPv6 addressing format. If you see address IPv6 address, it is how many digits? 32. Understand? Yeah. So how it is 32 now? Say 4. If you add now, you will get 16 plus 16, 32. So 32 hexa digits. In each 32 hexa divided into 8 groups, and each group will have 4 hexa digits, right? Yes. Now, if anybody asks you what is your IPv6 address, you need to say like this: 2001 colon 000 colon 000 colon 000 colon. But it is very difficult to say like this, right? Yes. Quite big. So what they did is they invented 2 rules. What is the meaning of this? The meaning is between this double colon, right? 6 groups of zeros is there. Computer knows that 8 groups is my IPv6 address format. So double colon, whenever I put double colon, in between it will add that many groups of 0 to more simplify. So what is 64? Sorry, that is our subnetting. This one, no? Right? /24. Acha, subnetting hai. Okay. Why na? Network bits, host bits. First 64 bits are this one left to right now. This is network bits. Yeah. In this 128 bits, first 64 bits are network bits. Yeah. N, H. Understand? No? H. Remember, right? Only thing is, there's no 255 concept here. There's no subnet mask like 255 or 255. That option will not. That is not there. Only slash only. In IPv6, there's no 255 concept. Yeah. So in IPv4, there is a subnet mask, right? Subnet mask, no 255. Then you convert into /24, /16, /8, right? Correct. In IPv6, there is no 255 concept. Directly, you will type slash only. /24 / whatever number you put, that left to right, that many bits are network bits. Yes. See, I already told you hexa format is 0 to 9 A, B, C, D, E, F, right? Any number, anything between this 16 numbers, it can come alphanumeric. Correct. Now what I am teaching here is why I use simple format is because I want to teach you the rules. If I put A, B, C, D means it will be more confusing for you, right? Understood. So the idea to keep it simple is to teach you the rules. Okay? Yeah. Next step, when we do the lab will come with all these things. The next step, I'm going to do the lab, right? See this lab. This lab you see, right? You can use this 2010. It's a little bit complicated, right? It's not simple. When you want to see the my command prompt, if you type ipconfig, you see this, right? Yes. This is what I'm saying. Yes. More complicated, right? Yeah. Understood. Yeah, so more complicated. So goes keep on complicating. And when we do the lab also, you can see that. When we do the lab, it will be more complicated. So we keep on growing like this. Understand? See, the idea here, why I am keeping it simple is to teach you the concept. In beginning itself, I will teach you algebra, right? You will not understand multiplication. Correct. So if you are asking like now, why algebra, you are not teaching me. but you don't know. I know you don't know multiplication. I will teach you algebra when you are ready for that level. Now, my idea here is very simple. I want to teach you the addressing format. I want to teach you 2 rules. Then next step, I'm going to teach you some more basics. Different types of addresses are there. Then when we do the lab, right, that time you see the real addresses. In lab, you will see what? Real addresses.
Okay.
But
Okay.
till that, I am teaching you the concept. I see this is the lab, no?
Yeah. Understood. Understood.
So the lab, you will see the whatever address comes in the real time. But till that, I want to teach you the concept. Whatever I want to teach you, that much level, only I will put complication. I will not give more complications so that you not understand the concept. That is the approach I am following. So now what I taught you is simple. Let me ask the question, see if you understood or not. What is the length of IPv6?
Hexa and
32 hexadigits.
32 hexadigit, and that would be in decimal and
So what is the full range?
yeah.
That is the full range. Permutation combination of any number can come. Understand? Then how this 32 digits is represented? How it is divided?
8 groups.
8 groups of. To make it simplify, it is very big. We follow 2 rules, right? What is rule number 1 says? Remove continuous zeros, put double colon. Rule number 2 says remove in group, remove prefix zeros. Means left to right you can remove. If it is right to left, you must not remove. Like 1000 is there, no, you cannot remove.
Yes.
Then because the value will change. 1000 will become 100 rupees. Correct, no?
Correct.
Left side you can remove how many zeros, but right side you cannot remove. Okay, that is done. Now I am going to teach you next thing. Next I am going to teach you IPv6. In IPv4, we studied 2 addresses. What are the types of addresses we studied? If you remember, can you tell me? IPv4. So if you remember, in private IP address range, we use class A, class B, class C.
ABC, right.
Yeah, only three classes we'll use. In that A,
so A is
172.16.0.02, 132.31.255 is free.
Registry would be this one.
Go to ISP. Correct. From ISP is get induced.
Right. Correct.
Right?
Yes.
So this all we studied already, right?
Yes.
This is the different types of IPv4 address. Now I'm going to teach you IPv6 address. IPv6 address, if you take, right, there are 3 types. 1, unique local. Let me see the unique or site. So there is multicast. Now in IPv4 we have broadcast, right? In IPv6 we don't have broadcast. Important point to be noted. In IPv6 no broadcast. We have unicast. No broadcast. Instead of broadcast, we have something called Anycast is something like you can configure same address to nearest machines. So at a time we can send one to one, one to group or one to many, or one to closest. Closest in the sense you can fix some addresses, some devices to my domain. I can use the same address to the domain, same address. And whenever you're sending a message to that address, it will receive that which are the machines you configure that address, no, that machine will receive the packet. That is one to closest. So in IPv6, remember in IPv6 we have unicast, multicast, and unicast, multicast, broadcast, correct?
Broadcast, correct.
In IPv6 we have unicast, multicast, and anycast. Clear? In IPv6 and IPv4 we will configure only one IP address in one interface, correct? Multiple addresses in same interface.
Okay.
Like for example, for your one house, how many address you will give for one house, right? But what you are going to do is you are going to give new address. Like that, you're going to create multiple address for same house. So when you want to send through foreign, I'll give this foreign address. Whenever you're sending through local, you will give local address. If you're sending through somewhere, it will give different address. Understand? So same interface, but I will give multiple addresses for multiple purpose. In IPv4, it is not there. IPv4 is having only one address you can configure in one interface, correct? So IPv6 it says configure multiple interface within your company, organization, within your organization you can configure. But if you want to go to internet, what address you want to configure? In IPv4, you use private address, right? What address you use for private? Private address 192.168. That is for LAN, within your LAN, correct? But whenever you want to go to internet, you use public IP, right? Same way here. Within your LAN, you use link local. You want to go to internet, use.
So sorry, there was a cut. So from link local to global.
See, it is equal to private IP address.
What I lost that.
So the global is used for like equal to public. See, in IPv4, if you compare, if you want to go to internet, you use what IP? Public IP, right? Which you purchase from ISP, correct? Same way, this global scope, you have to pay money and but link local and unique local, it will get automatically link. Unique local is free address. They have given one range. Within the range, you can use it. It's a free address. Like what they give 192.168, like that free address. This link local automatically gets configured. Automatically gets configured using MAC address. This is both you're not going to configure. Only thing if you want to configure, you can configure only. You have to pay money and buy the global scope address from ISP. Then you have to configure that. Understand? Now let's note down this. So again, I'll repeat. IPv6 have only unicast, multicast, and no broadcast. Instead of broadcast, you have unicast. Okay.
Right.
And IPv6 is having 3 addresses: link local, unique local, and as mentioned here, unique local is optional. If you want, you can use it. You don't need to use it. It is not mandatory. But these two are mandatory. And this link local automatically gets configured. You don't need to configure. Using MAC address, it automatically gets configured. Now I'm going to explain that also, how it is getting configured. Okay. Automatically gets configured. Global scope, you have to pay money and buy the address and configure it. So now whatever lab we do, we are going to configure global scope only. Understand? Okay. Because link local gets automatically configured, right? You don't need to configure that. So what we are going to configure is global scope address. Now I'm going to show you how it is getting configured automatically. There is some methodologies there from IANA to registries. So automatically from the service provider will pay money and buy. And the global scope starts from 2000. Okay. And the free address I told, no. Class A is 10, class B is, you remember, right? Free address in IPv4. Same way, this is the free address, like 192.168, like that, 10 dot like that. For there's no class concept here, so they have given you only one free address. Now link local, what I told you, link local, how it will be configured? Automatically configured using MAC address, correct? You understand?
Yeah.
Now MAC address is how many bits?
So 40,
remember, MAC address how many bits?
So it's 48, right?
48 bits. In that first 24 is called OUI, second 24 is called VA, correct? Right? We divide this 24, right? So see the method, right? What is the algorithm here is FE00. Remember, right? You saw here FE00, right?
Yes.
You asked me what is FE00 here, right?
Correct.
Right? See, FE00, then just put 00000, then 64 up to 64 bits 00. Understood? This is fixed. It's not going to change. Understand?
Yeah.
Then 48 bits. OUI is 48 bits. Then type FFFE. That is also fixed. FFFE is fixed. Okay. Then VA. VA is again 24 bits. 24 plus FFFE plus 24 bits. Understood? So how much it is? 24 is 48. 48 plus 16 is. Using the MAC address, IPv6 automatically configures local link local address. If we expand that to one FE80 double colon, below you will get like this. You see that? So what it is, this is the IPv6 address. Can you read the IPv6 address now? FE80 double colon, 21F colon, 3CFF colon, FE40 colon, 2F65. This is the IPv6 address, okay? It's alphanumeric, right? Now you got alphanumeric, right? But if you see that, actually how it is 128 bits, below they are given. Then they added the 0 in between. Before 21, no? They added one more 0. As per rule 2. Okay? So understood now? So again I'll repeat this. IPv6 has 3 addresses. In IPv6 you can configure in one interface multiple addresses. Okay? Point number 1. Point number 2, IPv6 have 3 addresses. Link local, unique local, global scope. Link local is used for LAN, which is automatically gets configured using MAC address. Unique local is free address. The range is FC00 /7. That is the range. And the global scope is which is used in internet. When you want to go to internet, you have to use global scope address, which has to be purchased from ISP. So who will give to ISPs? ISP will be purchased that from the registry. Goes to INA.
Correct.
Right? Clear, right?
Yes.
This is the theory I want to teach you. Now we'll do the lab. First command is to enable IPv6. You have to configure IPv6 routing, unicast routing. What is the command? IPv6 unicast routing. that will enable the IPv6 in the router. Then you have to go to the interface and you have to configure that interface IP address. So the command is IP address, right? Here IPv6 address. And the IP address is just /64, no 255, no concept, okay? Type the address and type /4. Now what is the addresses we have? Let's understand that first.
Colon 54 colon 1-64.
2001.
210 and then 10 and then 1 and then
10.
colon 164.
Double colon. Okay.
Okay.
See, this is one network. 10, 20, 30, remember? This is one network. This is one network. 3 networks. Now each network has a network address. So what are the network addresses? So how do we find network address? What is the formula to find network addresses? All host bits are 0. If you make all in IP address, if you make all host bits 0, right? You get network address. That is the formula. If you remember, right? IPv4 formula. How to find network address? You put all host bits are 0 in network address. All bits are 1 means broadcast address. Remember? That is the formula to find network address and broadcast address. Last question. If you remember that formula we studied in IPv4 basics, right?
Right.
So the same formula I'm going to use here to find network address. But the difference here is it is 128 bits, not 24 bits. Understand?
Okay.
So first 64 bits are network bits. Next 64 bits are host bits. So how do you write down this? Actually, if you write down this 2001 0055 0000 0000. How many zeros? How many groups? 4 groups, right?
4
groups. Yeah. So
another 4. Total 8.
1/64. Actually, this is the actual address, correct? So what I'm going to do, the formula, what is the formula to find network address? The formula is in IP address, all. Now I'll apply this. Formula. If I put all host bits are 0, it look like 0 here also. To simplify this, how do I write down this? 2001 colon 55 double colon /64.
IPv6 address.
Network address. Understand?
Network address, yeah.
This is one network address. Second network address is
2001
210 1 double colon /64. Total 8 groups, no?
Correct.
Then again 2001.
Only 56, yes. Earlier it was 55 and now it's 56. Correct,
na? Now what is the syntax to create a static route? Static route syntax kya hai? You remember the syntax, command syntax? I'll write down the syntax for you, okay? See, in IPv4, the command syntax is very simple. If I want to add a route statically, manually, right, what is the command? The command is go to that particular router, global mode, then just add IPv6 route, destination network address, prefix here, no subnet mask, okay? Tell this is the destination network I want to go. This is the next device IP address. You have to say that much at least, no? So then how do you add a route? What information tell the router? I'm going to add IPv6 route. This is the destination network address, and this is the subnet mask //64 or whatever. Then, if you want to go to this network, please go to this IP address.
Right. Correct.
This is minimum, no? How do you say a route?
Right.
Destination network address.
And then
next device IP address. You have to say minimum this much. You have to say right.
Yes.
If you understand this, you see this now, right? See the command is very, very simple here.
Yes.
You understand this. You want to go to 56. You remember 56, 54? So R1 is saying if you want to go to 56,
55.
This is the next device.
Okay.
Same way R2 is saying if you want to go to 55, same command IPv6, wherever IP you put IPv6 also. So IP route, no IPv6 route. So IP interface with IP ping.
Okay.
Now this is actually static. Now if you see dynamic, right? Dynamic is very, very simple. Yesterday we saw dynamic. So what we did here, we enabled the routing, we add the interface.
Interface, right.
So how we did, we put network command, just direct content, network address, wildcard mask, area, so many things, right? In IPv6 is very simple. Just go to the interface and tell boss, you are IPv6 OSPF area, this area. Now, but service provider level, no, they have migrated to IPv6 because they don't have that much
service
IP addresses
provider
available.
level. Okay. It's yeah. I mean, lots of analysis is required. But this is good. I
They
mean,
need so many IP address.
right.
That's why they are moved to IPv6. But end user level, it is applications are working with IPv4. Whenever the application says no, I can't work with IPv4,
Hmm.
now the migration method is both are used. I told you,
Okay.
right, how they are migrating
Interesting.
now is
Interesting. Yeah. Yeah.
now old address, new address, both address is there in your card. You send your address letter post. You write both address, old address, new address, right?
Okay.
Old number, new number, correct? So
Hmm.
who are using old number, through old number they will get that located. New number, new number. One the moment everybody get the new number, you remove the old number, correct? Same way
Correct.
now all the devices are using both addresses, IPv4, IPv6. Which
Okay.
is
Okay.
using IPv4, they use IPv4 and communicate. So your house address is there, no addressing format.
Hmm.
In older
Hmm.
format, no, it has small address. Like
Yeah.
for example, door number 7,
Hmm.
street 7th Street, Gorakhpur. Now
Hmm.
what happened? Lot of sector,
Hmm.
cross, main, so many things came because the city has developed. So now the new address is door number
Hmm.
7, 25th sector, 25th main, 7th
Hmm.
cross, 16th
Hmm.
sector.
Hmm. Hmm.
You know,
Hmm. Hmm. Hmm.
so many extra things got
Yeah.
added.
Right. Right.
So what?
Understood.
That's the only difference, right? Address is changing.
हाँ
Whereas
अभी समझा
function
yes
is
yes
function
yes
is what?
okay understood
Because the reason of adding all these things are it's becoming bigger. The number will not suffice, right?